we have just an example of water molecule. This is a water molecule, and water is called a universal solvent. Now, it doesn't dissolve everything. But of any liquid that's out there that you would use to dissolve the most type of compounds, water is the best. Okay, water will dissolve most everything. Doesn't mean it's going to dissolve everything. We say it's a universal solvent, but it dissolves a lot of things. And this is how it attacks sodium chloride, for example. If you look on here, the oxygen is the negative part of the water molecule. It's really not negative. It just has more of the electrons than hydrogen does. So we say it's polar. Okay? And when we say it's polar, that means it's going to be attracted to the positive ion and pull off that positive ion. So this is what it does, is it comes in there and it pulls off that sodium, the oxygen does. Of course, you can't see that in the solution, but it comes in here and pulls that off. Okay? And then this hydrogen part of the water is slightly positive, and it will pull off that negative ion. Okay? And it just does that until it's all dissolved. Now, there comes a point where it can't dissolve anymore, and that's called a saturated level. And we're going to talk about that and look at a chart today about that. But it gets to the point where it's saturated. Okay? And so ionic substances can usually are pretty soluble in water. But they're not soluble in some other things. Okay? Ionic compounds. So this is an example if we try to put a nonpolar substance into a polar substance. They're not going to mix. The reason they don't mix is because each one of these waters attract one another. So for methane to get in, it can't get in. You guys ever play Red Rover, sing so, Red Rover?
Yep.
Okay? So basically, this is like, these are the really strong guys that you try to go through, and you kind of go like this, and kind of go on your back. Okay? You always try to pick the weakest link, right? Where you think it's going to be in Red Rover. This methane can't get in there. So if it can't get in there, they won't mix. And that's why polar substances and nonpolar substances don't mix. Now, nonpolar is okay to mix with nonpolar because there's nothing holding them out. They'll just kind of distribute evenly throughout because the substances, the motion of the particles just allow them to be equally distributed. So that's kind of what they talk about when they talk about solutions and kind of how they form. If you look on page 362, kind of has show the water molecule in a similar way. And they talk about certain things that are soluble and insoluble. Go to page 364. What I just showed you, page 364, that's what's happening there. Okay, the salt is being hydrated, meaning that the water surrounding each of the ions, they kind of surround them. And they just keep pulling them off until they get to a point where there's way too many to pull off. Okay, so they do a really good job of showing some of those examples there. Just want you to be conscious of that. Kind of know that polar dissolves polar, or ionic. See, ethanol's polar. So if I had ethanol in here, will it fit in here? It will if it has hydrogen bonding. So here's ethanol. And the question is, will ethanol fit in here? And the answer is yes, because it has the OH. And it can come in, and now the H is attracted to that O, and the O is attracted to that H, and they mix. But the top one, they won't mix. Okay? All right. You guys have any questions on page 365, the electrolyte, non-electrolyte, and weak electrolyte? Non-electrolyte when you dissolve it, it won't conduct electricity. A strong electrolyte, when you dissolve it, will conduct electricity. A weak electrolyte is called a weak acid. And here in a second, I'm going to put these three up here, and I'll give an example of all three that you can write down in your notes. Yes?
So like in Gatorade and stuff, they was talking about electrolytes. Is it like the same thing?
Right.
So
It's going to have both. It's going to have non-electrolytes in it for taste, and it's going to have electrolytes in it.
replenishment.
Right, because when you sweat, your sweat is salty. Okay, it's salty because it's losing water, but it's also losing the salts. So if you continue to sweat and sweat and sweat, then what's going to replenish those salts is electrolytes. And this really has enough electrolytes for the most part, unless you're really, really sweating. Then you might need some sort of electrolyte. Okay, I think Pedialyte has a lot of electrolytes in it. Do you guys know what Pedialyte is? Okay. So some babies, when they get super, they got diarrhea and they're super, and this happens to all kids. They get to the point where they're losing way too much fluids. You got to give them Pedialyte because they've got to replenish those electrolytes a little bit quicker. So that's why they have the Pedialyte instead of something else along those lines. Okay? Now, I'm going to give you two types of saturation here. I'm going to give you a definition for solubility, and then I'm going to give you saturated and unsaturated, and you guys can write that down. Take 2-3 minutes to do that, if you would. So what I'm going to do is show you a supersaturated solution. I'm going to wait for this one at the very end, because this has to be at room temperature, and it hasn't set long enough to get there to be supersaturated, so I'm going to let it kind of sit. I'm going to show you it in this form, and I got to find my packet, what I did with it. Oh, here it is. Okay, so we're looking at the chart, figure 12.5, and here's my first question. There's your first question. Go ahead and answer that. So your choices: unsaturated, saturated, supersaturated. That's all you can put down. Okay, so go ahead and do that. This is 2. So 1, I'll come back to this real quick. So 1, to finish it up, what type of solution is formed when 160 grams of Ki is mixed at 100 grams of water at 60 degrees Celsius? And number 2 is asking for what type of solution is formed when 140 grams of KNO3 is mixed with 100 grams of water at 60 degrees Celsius. So that's question number 2. Now, if you guys notice, I'm always prefacing 100 grams. Last year, we don't have time to do it this year, and I don't want to do it. But last year, I would say, to make it more complex, I'd say, well, how much can dissolve in 200 grams? So if I said how much can dissolve in 200 grams, you're going to do what with your... You're just going to double it, right? You can say, well, I can dissolve twice as much. And then I would ask you, and then I'd ask you, what's the solubility of it? And then you would say, well, the solubility is the same. It's still only dissolving X number of grams per 100 grams of water. So it doesn't change. It's just they set that as a guideline. 100 grams is kind of their, that's kind of easy. That's 100 grams right there. And that's what they're looking at. Okay? And then I got one last question. I'll go back. Okay, so and I'll go back to that original slide again, but this is question number 4.
Do we need a temperature?
Oh, yeah. Oh, yeah. While you guys are answering those questions, have you guys noticed the gases on that chart? Their numbers range in milligrams from 0 to 8 milligrams, where the other chart is measuring grams. So gases aren't very soluble in liquids. That's because they're molecular. Molecules don't dissolve well in water because they're nonpolar. They will dissolve, but not very well. So that's why it's in milligrams per 100 grams of water. And the solids are grams because they do a much better dissolve. Ionic compounds do a much better job of dissolving. So let's go through, answer these questions here real quick. Then we're going to take a look at Henry's Law. I got a demonstration for that. Hopefully this will cool enough where I can show you this one. I'm going to run some water over it and try to cool it a little bit. All right, you guys ready? You get 100? Okay, we'll see. Yep.
That's not even going on with the questions.
It is a little bit. Okay. 1. So what type of solution do we have?
Unsaturated.
Is 160 below the maximum it can hold at 60 degrees? Okay. So when you go up at 60 degrees and you go up and you intercept 160 grams, you find out where it is corresponding to the line for the saturated level at 60 degrees. And I think this Ki, when you look to see how much it can dissolve like 170, about 171, 172.
Yeah.
So got 160 grams and 170, around 170 can hold. So to make it saturated, I'd have to add how many more grams? About 12 more grams. I'd put 12 more grams. I would put 172 and then it'd be way over. Okay? Wouldn't dissolve. So I can say how much I can dissolve more, or I can say, so this is unsaturated. Long story, unsaturated. Next one, and a lot of this is ACT type of questions. They'll ask you, and they're really pretty basic ACT type questions. They say, all right, the following solution, I have this many grams in 100 grams of water. What kind of solution is it? And then you go think, oh, that's unsaturated. And then they might ask you a second one, and they'll say, well, how much more can dissolve of it? And you say, well, it can go up to 172, so 12 more grams can be placed in it. So what type of solution is formed when 140 grams of KNO3 is mixed? 100 grams. So 140 is over.
Yeah.
So how much can it hold at 60 degrees? About. And that might be a guess amount.
Like 120.
I don't know. You guys tell me. About 120?
Oh, what
You
is
say?
it?
KNO3.
112.
Yeah, 112, yeah, precise.
Okay. But we know it's probably supersaturated. So you guys would put supersaturated, and based upon the question, it would not be supersaturated. Because what do you have to assume to know it's supersaturated? Okay? The way it's saying, hey, I'm going to take 140 grams of this and put it in 100 grams of water at 60 degrees. You're assuming what if you say that it's supersaturated? That all of it is dissolved. Does it say that all of it dissolved?
Nope.
No, it just said I put 140 grams in. So what kind of solution is it then?
Saturated.
Saturated. Does that make sense?
We don't know if it will be.
Right, it doesn't say, it just says it mixed. It doesn't say that anything but, just mix the two. So there's some solid left over at the bottom probably. Okay? Number 3. How many grams of NaNO3 will dissolve at 40 degrees Celsius? This is a real basic question. 100 grams? You guys agree with that?
Yeah.
Okay, good. About 100 grams. Now what if it said at 60 degrees Celsius?
120.
120? Okay, and that would be saturated at that point. Okay. So the temperature is very important. And in this last one it says if we have 80 grams of KNO3 that dissolves at 40 degrees Celsius, what kind of solution is formed? Now what tells you it's supersaturated? Dissolves. Means it's all gone. Okay, so how do you do that? Well, how you can make a supersaturated solution is to, and this, I got to recharge these, and this is how it says to recharge them, so I can use them again. Wrap solid pack in a cloth and place in boiling water for 10 minutes. So what happens to the solubility of this as I put it in at 100 degrees Celsius? Goes way up. And when it goes way up, do we see a solid anymore? No, it's going to be a solution like it was before. So I have to put these in hot water to recharge. And then once I recharge them,